Testing. Testing. Hey folks, here you have a Lego Uno R3. So this Elegoo UNO R3 is just a cheaper version than an Arduino. It's like 20 bucks. Arduinos are like 50. Arduino. So I configured this thing to trigger pins 2 and 4 output at 5 volts. And let me share the screen here. Window. You can see here, this is the that's the code. I just altered it. So I'm going to slow it down so you could see the flashing better. I had pin 2 to stay on for 5 milliseconds. That's why it looks like it does now. Give me a second here. Yeah, so I'm going to configure it to, instead of having pin 2 to be high for 5 milliseconds, I'll have it stay on for 25 milliseconds. I really want the duty cycle to be real short for this circuit. And the circuit is the flyback generator circuit. Give me a second here. I'll bring up the circuit. Open source, by the way. So if anybody wants to build it, you are free to do so. That's the circuit. Sorry. Let me add this. Okay, that's the circuit, and you all know this circuit already. If you've been following the channel, you know this circuit. And so I'm using the Elegoo UNO to trigger this circuit. And yeah, so this will be the circuit I'm using to trigger it with. I mean, this is the circuit that's going to be triggered. You see the two right here and here, the two switches. Well, those are going to be transistors being triggered by this Arduino here. And Excuse me a second here. I'm getting used to this. Uh, Getting used to this StreamYard. Okay, so and there is the code again. I am going to now slow it down. 25 milliseconds on, and instead of 100 milliseconds off, I'll have it 250 milliseconds off. I'm increasing the duty cycle a little bit on the on time, and I'm also increasing the off time a little bit. Now I'm going to upload it. You see how it slowed down there? So having the duty cycle off is, for a longer period of time, having the duty cycle off is to your advantage, because you'll use less power and you'll lose less power. So when you pulse the inductor with DC pulses, try to make the duty cycle as short as possible, and to increase the off cycle time, it should give you a higher spike. So I'm going to go back to the coding here and lower the off time from 250 milliseconds to, let's say, 50 milliseconds. And it's on for 25 milliseconds. Let's see if we can have it on for 15 milliseconds instead of 25, and off for 25 milliseconds. We have two pins being triggered here. This is basically going to replace any non-solid state trigger method such as a rotor. Let me upload this. Okay, it's uploading, and bing. Well, it's pulsing faster. So I don't know what that frequency is, but once you get it running, you can always measure the frequency with an oscilloscope and then adjust your duty cycle with the Arduino here later. Let's try having it off for 100 milliseconds. Let's see, we got it on for 15 milliseconds. For 50. On for 15. Off for, let's say, 500. See what that does. Ah, look at that. Ta-ta, 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 ta-ta. So I'm going to have two electromagnets here on this circuit. um, so let's see how to do this here. Give me 1 second here. Where is it? Flyback Oscillator. And this circuit is going to have it's going to have so yeah, so that's the trigger circuit. It's going to be in a Elegoo UNO, or what you know as Arduino UNO, and it will be triggering two transistors. Let's go 50 milliseconds off, on for 15. Let's see what that does. That's more like what I'm looking at doing there. On off, on off, on off, on off, on off, on off. So conveniently, one LED is red and one is blue to show. I don't know. Doesn't really. The blue doesn't mean anything. Just two different triggers. Two different triggers. Let's shorten the duty cycle to 5 milliseconds and have it off for 10 milliseconds. And that will increase the frequency. We're shortening the duty cycle and the off time. Let's upload that. Should be faster now. Look, it's so fast you can't even see it blinking. But off camera, I can see it blinking. That is blinking fast. I'm going to slow it down to, see, 200. I'm going to increase the off time here. Maybe that's off for just a little bit too long. Let's go 20. Still too fast to see it blinking. But yeah. Do 50. Let's see, 1 millisecond. What happens when you have it on for 1 millisecond? Let's see what that looks like. And off for 50 milliseconds. Oh, look at that. It's a lot dimmer because you're not giving, which is probably better, because you're not giving enough time on time for the LED to light up fully, but it's enough to trigger the transistor. And in this way, you're using a lot less power. And that's the goal here. So it's on for 1 millisecond, off for 50 milliseconds. Let's just do 25. On for 1 millisecond, off for 25 milliseconds. Let's see what that looks like. Whoa. The camera's picking up the pulses. I like that. I like that oscillation there. I think that's good. On for, well, that's the code there. Pin 2 is on for 1 millisecond. Very, very short duty cycle. I don't think you can change the volts. Not digitally anyway, but you can add a resistor to lower your 5 volts down to a lower voltage if you want to trigger the transistor even more gently. Yeah, so that's my presentation for today. And just to give you guys an idea of where I'm going with this circuit, I plan on triggering it with this guy right here. So that we can have a solid state version here. You can always use a rotor, and you can use a rotor to trigger your transistor like the Bedini system. But for whatever reason, I want to go solid state. Probably because I can fine tune my frequency and keep it stable. So once I get this running on the 2 electromagnets bouncing back and forth to flyback, I'll easily be able to measure the frequency with an oscilloscope and then adjust the code accordingly. Alright guys, hope it makes sense. Over and out.